Okay, in this lecture, we are going to see about the topic of voltage regulation of a transformer. Now, whenever we are talking about voltage regulation, we need to understand what this concept is basically. So, if we are defining voltage regulation, so the voltage regulation is defined as the arithmetic difference between the secondary terminal voltage at no load and full rated load at a given power factor with the same primary voltage for both rated and no load. So what does it mean? There are actually two conditions. The first condition is that you are loading a transformer on the secondary, and at the first condition you are not providing any load. Okay, so if there is no load, that means the switch S2 or sorry, the switch S is open. So if switch S is open, so the current which is there in the secondary will be zero. So at that point of time, whatever the voltage is, that will be stated as V no load. And you can see due to the principle of electromagnetic induction, the voltage which will be induced will be E2 itself. So you can say that V2 or the no load voltage is equal to E2. And there we are assuming the second case. The second case is that whenever you are closing the switch, so whenever you are closing the switch and at the secondary side you have connected a full load, the voltage at the secondary side would be the full load. So what do you mean by full load? So full load means you are loading the transformer in such a manner the secondary side is carrying the full load current. So the secondary side has to carry the full load current. It means that the transformer, suppose the transformer is rated at 2 kVA. Already I have been using this example more often, and the secondary voltage is rated at 200 volt. Okay, so what will be the rated current at the secondary side? That will be the rated current at the secondary side would be the full load current. It will be 2 into 10 to the power 3 upon 200. So it will be 10 amperes. You are loading the transformer in such a manner that 10 ampere current is flowing through it. So this will be called as the full load condition, and at that condition the voltage which is recorded is V2. So the difference between the no load voltage and the full load voltage would be termed as the voltage regulation. So no load voltage we have seen when no current is flowing in the secondary, the no load voltage is E2, which is same as the induced voltage at the secondary winding. And when we are loading the transformer with full load such that the rated current at the secondary side is flowing, at that condition the voltage which is recorded is V2. So the difference between the no load voltage and the full load voltage would be termed as the voltage regulation. This is a performance parameter of a transformer, and this parameter represents the voltage fluctuation, and it should be as minimum as possible for a good transformer. In the second slide, we are going to see this very particular concept of percentage voltage regulation. So we have already defined what is voltage regulation. It is the difference between the no load voltage to full load and full load voltage. And this difference, if it is being expressed as a percentage of full load voltage, so that will be termed as the percentage voltage regulation. So percentage voltage regulation, you do find two different types of expression or two different types of nomenclature according to the books. In other books also, you will be finding the percentage voltage regulation as E2 minus V2 divided by V2 into 100. Okay, so if you are multiplying by 100, you will be getting the percentage voltage regulation. Okay, so this defines the percentage voltage regulation. Now the thing comes is that what is the formula for voltage regulation? So we are about to calculate the mathematical formula for voltage regulation, and for that what we have assumed a secondary circuit. So we have assumed the equivalent circuit of the transformer referred to secondary, And over here, what we have considering is that already the equivalent circuit referred to the secondary side has been discussed. That means whatever the primary resistance and the primary reactance which were available, that has been taken to the secondary side, and the entire two circuits of a transformer has been represented as one circuit. So the net resistance, what you are getting is that is R02, and the equivalent total reactance at the secondary side is X02. And for the sake of simplicity, we are not considering the no load equivalent circuit, that is R0 and X0. So if you are taking this particular circuit, in this particular circuit, the current which will be flowing through the secondary circuit will be I2, and the applied voltage is E2, and this applied voltage is meeting the voltage drops R0 to X0 to, and finally it is supplying the voltage V2. So you can write the phasor equation. E2 will be equal to I2 into R02 plus J I2 into X02 plus V2, and the phasor summation can be written as E2 is the phasor summation of the voltage drop across the secondary side impedance, that is Z02, and the voltage across the load terminal, that is V2. So for the calculation, we need to understand a phasor diagram, and whenever in the next slide we will be discussing the phasor diagram. In that phasor diagram, we will be taking V2 as the reference phasor. So the V2 will be taken as the reference phasor, and when you take V2 as a reference phasor, you get a phasor diagram like this. Now see, we'll be understanding the phasor diagram one by one. So first we have drawn V2. Okay, so it is the reference phasor. So it is, it does not subscribe any angle, and we are assuming a lagging load. Okay, so we are assuming the lagging power factor load. The load current is lagging the load voltage by an angle phi 2. Okay, so that's we have taken. Now the our job is to get the value of E2. So whenever you are finding the value of E2, the E2 is the phase summation of the impedance drop and the terminal voltage. Now if you want to get this impedance drop, that is I2 into Z ZE2 or Z02 for that matter, which I had written in the previous slide, what we can do, the impedance drop will be composed of two parts. So first will be I2 into RE2 drop or IR drop. Okay, so whenever you are having an IR drop, so for drawing the phasor of IR, you will be drawing in such a manner that it is always along the current I2, because whenever there is a resistive component, the voltage across the resistive component will always be along the current. So I2 into R02 has been drawn parallel to I2. And next, what you will be doing is that we have to show the impedance drop, that is JI2 into X02. Okay, so in this diagram it is represented as Xe2 and X02 both are same. Okay, so Ji2 into X02. So Ji2 into X02 would be leading this voltage by 90 degree, because you are having the J factor. So the J factor will make the phasor lead by 90 degrees. So what you are getting, we are getting the I2 X02 phasor perpendicular to I2 into R02 phasor, and you add this two phasors algebraically, sorry, not algebraically, with the phasor summation, you will be getting the resultant. The resultant phasor would be like this. So the resultant phasor is AC, and if you are joining AC and OE, you will be getting the phasor E. So what you are getting finally, E2. E2 is the resultant phasor. So E2 will be equal to your V2 plus I2 into Z not 2. Okay. So we have expressed this phasor over here. Now look at over here carefully. We will for calculating the voltage regulation, will be making use of this triangle, and we will be extending this triangle from the point B to point G, and we'll be giving a drop down from point C to point G. So we are getting another extended point, that is point F, and from point B again we will be making a perpendicular, that will be BD. Okay, so what you can write from here is that you need to basically get the magnitude of E2. Okay, so from this triangle, if you are writing the magnitude of E2, the magnitude of E2 will be obtained from this particular right angle triangle. The right angle triangle which you must focus is triangle O, F and C. Okay, so you have triangle O, F and C. Okay, so from this particular triangle, you can get the value of E2. So you have a right angle triangle. You can write OC square. OC square is equal to OF square plus FC square. Okay, plus FC square. Okay, so OC is nothing but is your E2. Okay, it will be E2 whole square, and basically our objective is to find out this difference E2 minus V2. Okay, so from where you will be getting the V2. For V2 you can expand this OF. Okay, you can expand the triangle or sorry, the line segment OF as you can expand as OA plus AD plus DF. Okay, so all those expansions you can do. So you will be getting the line segments, the terms in terms of E2 and V2, and this is what you will be seeing in the next slide. Okay, so what we have done, we have expanded OF as OA plus AD plus DF, and CF we can write it as the difference between CG minus FG. So it won't be FC, it will be FG. Okay, so you can write the equations of the triangle are to be followed, and you will be getting V2 plus I2 AD. What is AD? AD would be I2 into R0 to cos phi 2. Okay, so this particular right angle triangle is to be seen. Okay, this particular right angle triangle is to be seen. So this will be giving you I2 into R0 2 into cos phi 2 plus df. Okay, so if you are having df, how can you write df? So df can be written as I2 into x0 2. Okay, I2 into x0 2 sine phi 2. Okay, so how can we? Okay, so as I was discussing about df, how can you write down the value of df? The value of df would be equal to this particular line segment, that is bg. So bg would be I2 into x naught 2 cos of 90 minus phi 2. Okay, so I2 into x naught 2 cos of 90 minus phi 2 can be written as sine of phi 2. Okay, so that this will give you this df, and then you have cg. CG can be written as from this triangle you can get the value of CG. The angle subscribed over here would be phi 2 only, and the value of CG would be I2 into x0 into cos phi 2, then minus I2 into R0 to sine phi 2. That is the value of FG. Okay, so the value of FG is same as the value of DB. Okay, and from this triangle we can write it as I2 into R0 2 into sine phi 2. Okay, so this is the understanding that how you are getting these terms, and if you are putting all the values, you will be the final value of E2 which you will be getting, that will give you the exact value of voltage regulation. So obviously the exact value of voltage regulation formula is a bit complex. We have the process to simplify it. So for that we'll be going to the next slide, which will be dealing with the approximate value of voltage regulation. So whenever we are doing the approximate value of voltage regulation, we are neglecting this very particular term. Okay, So if this very particular term is being neglected, the simplified equation of E2, what you will be getting as V2 plus I2 into R02 into cos phi 2 plus I2 into X02 into sin phi 2. And from here you can get the difference as E2 minus V2 as I2 into R02 into cos phi 2 plus I2 into X02 into sin phi 2. And this particular formula is to be remembered. And see, for the first year point of view, if you are able to remember this particular formula, this is more than enough. And the triangle analysis is just for the understanding. So the voltage regulation for the lagging power factor would be this value, and if you are finding the percentage voltage regulation, it would be divided by V2 and into 100. You will be getting the percentage voltage regulation, and also mind that you have to put I2 with R not 2. Do not mistake this formula as I2 into R2. That will again give you a wrong result. So you need to refer the transformer entirely to the secondary side, and you obtain the value of R02 and then X02, and then you put it in the formula. The another part what we can have is that we can have for the leading power factor. So if the load connected in the and secondary is leading in nature, the phasor will change. Okay, so instead I2 being lagging, it will be leading V2. Okay, so it will be leading V2, and accordingly you can create the corresponding phasor diagram. So this will be I2 into R02, and from here you will be getting the value of I2 into X02, and you will be joining this phasor that will be giving you I2 into Z02, and finally you will be joining this particular phasor for the value of E2. So if the analysis is being done, the simple change what comes is that instead of the plus sign, the minus sign comes appears, and you can get the value of the voltage regulation if the nature of the load is leading. And this particular formula can be used to find the voltage regulation. So this completes the explanation of how to determine the voltage regulation in a transformer. Thank you very much.